physicists have long been puzzled by a fundamental question: is light a wave or a particle? In the 17th century, light was believed to be a wave, and the phenomenon of interference was the most direct proof of this. When beams of light intersect, interference fringes appear. However, in the 18th century, Newton argued that since light travels in straight lines and reflects off surfaces, it must be made of particles. Given Newton's dominant influence in the field of physics at the time, the particle theory of light prevailed throughout the 18th century. This led to a significant divide in the scientific community. Wave theorists and particle theorists each developed their own theories and firmly believed in their correctness. In the 19th century, British physicist Thomas Young, supporting the wave theory of light, conducted the famous double-slit interference experiment. Young set up a barrier with two narrow slits. He reasoned that if light were made of particles, passing through the two slits would result in two lines corresponding to the slits. However, if light behaved like a wave, it would pass through the two slits and produce two overlapping waves, causing interference, just like ripples on a lake. The results were exactly as Young predicted. Clear, zebra-like interference fringes appeared on the screen. This not only marked a significant victory for the wave theory, but also demonstrated that authority does not necessarily equate to truth. With the rise of quantum mechanics, this experiment became even more mysterious. In Young's original version, light photons were fired in a continuous stream, allowing for the possibility of interference between photons. Physicists then conducted a second experiment. The photon gun was switched to single-shot mode, ensuring that only one photon was fired at a time. Each photon would pass through the slits alone, meaning there would be no opportunity for photons to interfere with each other. Theoretically, the screen should show two distinct lines. However, the results shocked everyone. Initially, with fewer photons, the screen displayed seemingly random dots. But as more photons were fired, the interference fringes, bright and dark zebra-like stripes, began to emerge again. According to the wave theory, the fringes result from wave interference. But if a single photon can only pass through one slit, what exactly is it interfering with? To investigate further, physicists conducted a third experiment. They added a high-speed detector in front of the slits to observe which slit each photon passed through. Once again, photons were fired in single-shot mode. The detector revealed that each photon did indeed pass through either the left slit or the right slit individually. It did not split into two. Just as the physicists were puzzling over what a single photon could possibly interfere with, something strange happened. The interference pattern on the screen disappeared and was replaced by two distinct lines. After repeating the experiment multiple times, physicists discovered a baffling result. When no detector was used, the interference fringes always appeared, indicating that light behaved as a wave. However, when the detector was added, the fringes disappeared and light behaved as particles. This led to the astonishing realization that the nature of light, whether wave or particle, depends on whether or not it is being observed. This is the true mystery of the double-slit experiment. To explain this phenomenon, quantum mechanics suggests that physical quantities do not have definite values before measurement. This idea, that observation itself determines reality, was highly controversial. Many scientists refused to accept it, with Einstein being one of the most notable skeptics. He believed that the universe is objective and deterministic, famously stating, "God does not play dice with the universe," to reject the randomness inherent in quantum mechanics. So, what do you think of this bizarre and thought-provoking double-slit experiment?